Hello everyone. This is a video tutorial on exponential functions. When you finish this tutorial, you will be able to graph exponential functions by using its characteristics and transformations. So let's get started. First, we will define an exponential function. Then we will investigate its characteristics and transformations. Lastly, we will graph exponential functions. The definition of an exponential function is just what you would expect, with slight modifications. The first modification is that the base of the exponent must be a constant greater than 0. Second, the exponent must be a real number. For instance, f of x equals 3 to the x power is an exponential function. The base is a positive constant and the exponent is a real number. However, f of x equals x to the third is not an exponential function because the base is a variable. Knowing certain characteristics about the standard graph of an exponential function will be useful in graphing its transformations. First, the domain is negative infinity to positive infinity, while the range is 0 to positive infinity. All graphs in standard form will have a y-intercept at 0, 1. The horizontal axis is the asymptote. If b is greater than 1, then the graph increases from left to right. Otherwise, f is decreasing. This is an illustration of the graph of two exponential functions in standard form. The graph on the right is the graph of an exponential function with a base b greater than 1. On the left, we have the graph of an exponential function with b between 0 and 1. The horizontal axis is the asymptote, and the y-intercept is at the point 0, 1. Now that we know what the graph of the standard form of an exponential function looks like, let's add transformations and analyze how the graph will be modified. When you add or subtract c units to or from the function, the graph will be shifted up or down c units. When you add or subtract c units to or from the exponent, the graph is shifted left or right c units. When you multiply the function by -1, the graph is reflected across the x-axis. A negative exponent reflects the graph across the y-axis. Multiplying the function or exponent by c units stretches or shrinks the graph by c units vertically or horizontally, respectively. Let's look at some examples. The graph of f of x equals 2 to the x power plus 2 is the graph of f of x equals 2 to the x power with the following transformations. Shifted up 2 units, the horizontal asymptote moved up 2 units to y equals 2, the y-intercept moved up 2 units to the point 0, 3, and 2 additional points are plotted for shape at 1, 4 and 2, 6. Let's see the graph. This is the graph of f of x equals 2 to the x power plus 2 with the noted transformations. The graph of f of x equals 2 to the x plus 2 power is the graph of f of x equals 2 to the x power with the following transformations. Shifted to the left 2 units, the horizontal asymptote at y equals 0, the y-intercept at 0, 4, an additional point plotted for shape at the point 1, 8. Let's look at the graph. This is the graph of f of x equals 2 to the x plus 2 power with the noted transformations. It's your turn now. This is the section of the tutorial where you get to practice what you've learned. Don't hesitate to go back and review to help you along in this section. Complete problems 1 and 2 and post your answers in the comment section below so I can see how well you're doing. See you next time. Bye.